I haven't given any questions yet. So what we're going to have in this one, with regular numbers when you're doing long division, remember that first one, now I don't even know, let's say was it 2,748? Yeah? Or does it make a difference if I switch the numbers around? Are those different numbers? Yes, they are, right? So you would get totally different answer. If you remember the digits but didn't remember what order they were in, you'd probably get the wrong answer when you're doing that. The same thing happens with polynomials, although you're allowed to write polynomials in whatever order you want, but in grade 9 they said there's a preferred order. Usually write your highest power first. Well, that's so you don't mix up things partially in long division, because if you switched your numbers around, your hundreds and your thousands, they would be different numbers. Same thing here, when we go to do our long division, we're going to write it in the proper order. Otherwise, things will get messed up. So one thing we're going to do for long division is we're always going to write it in highest degree first, which is the highest powers, descending down to your ones, which is your constant. Then we look at our first term, which is 2x cubed. What would you have to multiply 2x cubed by? What would you have to multiply the x minus 1 by to get a 2x cubed? A 2x squared. I'll write that above my x squared column, multiply it through, I'll get 2x cubed. 2x squared times a minus 1 will be minus 2x squared, and I'll subtract. This, of course, will be 0. 3 minus a negative 2 be plus 5. And the rest of them are not subtracting anything, so they can just be brought down. Now my largest term is plus 5x squared. What would I have to multiply an x minus 1 by? Plus 5x. Notice how, even though it's just 5x, I put the plus sign here already because it's going to be a polynomial as my answer. So I get plus 5x. Multiplying that through, I'll get 5x squared minus 5x, and subtracting. This will be 0. Negative 2 minus a negative 5. Plus 3 minus 5. Now my biggest term is 3x. What would I have to multiply by? Why? Yeah, that is a very good question why that happens. That is totally a mistake, right? Good observation. The plus 5 just changed to a minus because it felt like it, and then it would still be a plus 5 down there. You will find in questions that this sometimes happens to you, that numbers just decide to change from positive to negative without telling you. They're jerks. Sometimes they can be that way. And then you check the back of the book and you have no idea why you got it wrong. Yes. That does happen quite often, unfortunately. Anyway, so now we have 3x plus 5, thank you. And that plus 3x, what would we have to multiply our x minus 1 by? Plus 3. 3 times x would be 3x. 3 times the minus 1 would be minus 3. And when we subtract, put it in brackets, 0, 5 minus negative 3 is plus 8. Okay? Of all the places you're going to forget to do, as far as making a mistake with subtracting, it's going to be in the last one. You're going to get so excited that you're almost done. And these are just nice, simple numbers. 5 minus 3, you're going to write, if you're going to make a mistake, it's going to be right at the end. Okay? And then you can write up here, remainder 8. So when you check the back of the book and you wrote remainder 2, that's probably the mistake that you're going to make. Okay, the questions for this one are 3, A, C, and D, and 5. Yes? Now, example 2, it says using a 0 as a placeholder. Zeros are very important because if you were getting paid, and this was your payday amount at the end of the month, which would be very nice, wouldn't it? And they just decided, well, zeros are nothing, we'll just give them $348 instead. That would not be very fun. So zeros are important. Where? Doesn't it say it in the example 2 right at the top? Using 0 as a placeholder at the top there. So what we're going to do, because zeros are important, for this one we're going to start off the same. You notice that it is in the right order, so that's the first thing you're going to check. Are my things in the right order? The biggest one is 3x to the 4, then I have a minus x cubed, but there are no x squared, so I put a 0x squared in there just as a placeholder. That's the only thing different with question number 2. We do the same thing. We look at our 3x to the 4. What would we have to multiply to get a 3x to the 4? A 3x cubed. Multiply that through. 3x to the 4 plus 6x cubed. Subtract. 0 minus 7x cubed plus 0x squared plus 3x minus 20. Now my biggest term is a minus 7x cubed. What would I need to do? Negative 7x squared. Easy negatives. And subtract. 0. Negative would be plus 14x squared plus 3x minus 20. Now my biggest term is the 14x squared. I'd have to multiply by plus 14. Oh, we didn't finish. I'll finish it up anyways. Plus 28x. I mean, the rest you can do on your own. I'll finish it up. If you want to watch the end of it, then you can at least see it. And when we subtract this, 0, negative 25x. And finally, need to choose a new color. How about fluorescent green? Ooh, can hardly see that. Negative 25x. Oh man, having trouble with my colors. Yeah, I'll be here at the end of lunch. 0. Remainder 30. So if we write our division statement, 3x to the 4 minus x cubed. And in your division statement, you don't need
Just a reminder for all staff and students that there is a pizza sale today in the front foyer. It's only $2 a slice. That's a pizza sale in the front foyer today.
what do I got?
$2 a slice.
3x cubed. 3. Did I make a mistake?
Seems like I made a mistake.
Oh, okay. Negative 7 plus 14x.
I have the same here.
Minus 25, and the remainder is 30. Plus 30. Just do a check at the back to make sure that we don't have numbers wrong. No, that is right. And this is our polynomial, our divisor, our quotient, and our remainder.
Minus 40 next.
All right, I'll just do that. You can do 3b and 7.